Okay, so we have another problem on mass moment of inertia. The problem says that the wheel has a thin ring, so that is and the mass of 10 kg, 4 spokes made from slender rods, and then each have a mass of 2 kg. So we have a thin ring, we have spoke 1, we have spoke 2, spoke 3, and then spoke 4. Okay, and each of them is 2 kg. And then determine the wheel's moment of inertia about an axis perpendicular to the page and then passing through point A. This is the axis that it looks for to find the mass moment of inertia. So the first step, as always, the table. We need to see what we have, yes. Let's go back to table. And then from the table we see that there is a thin ring. We have it. And then we have a slender rod, which is spoke. And then we can do the problem very easily. And then for the rod, we have the axis given as the y-axis or y-prime axis. We can choose any of them that we want. But if you come back here, so we can combine two spokes as one. Okay, because it is not, it will not create any problem. So this will be spoke 1, spoke 2, and that is like we have only one spoke. You can see only one spoke. Okay, and then similarly we will have this spoke. It doesn't change anything. Or if you go back to superposition, you can add the solid bodies. Instead of dealing with 4 different bodies, we can deal 2 of them at once. You see, they are together, they are connected. That's not a new, geometry. And then for this one, what we will do is that we will look for the mass moment of inertia. The book says that find around the axis this way. So we will look this axis. That's what we look for. Similarly here. That's what we are looking for. Then we go back to this table, passing through the centroid G, that is 1 by 12 m into L squared. Okay. The center point. 1 by 12 m into L squared. Be careful that we are, so if you do separately, for example, you do for this one, and you look for this axis, then you will not look for centroid, you will look for this part. Okay. But since we are not dealing with separately, we are dealing as a whole, we will take this one, 1 by 12 m into L squared. Okay, and then that will be 1 by 12 times the mass is 2 kg and then 2 kg, 4 kg. This is only for 1. By the L is 500, 500, so that's 1. squared, that is 1 by 3. Okay, similarly, or not similarly, exactly. So we have spokes. I is 1 by 3 plus 1 by 3. We can add them, yes. That's what the superposition principle says. We can add them, no problem. Now comes the thin ring. And then for the thin ring, if I go back to here, we have z, y, and then x-axis. As you can notice that the case in our problem was this one. Okay, and it was rotating around this axis. Okay, that's the reason that we have to take the z-axis, which is m into r squared. Okay, the mass of the ring is 10. R is 500, so it will be that 10 times 0.5 squared. That will be 2.5 kg into meter squared. I will be the wheel, I of ring plus I of spokes. 1 by 3 plus 1 by 3 plus 2.5. Okay. So 2.5 plus 3.17. But this is with respect to central axis. The question says that I with respect to A. That will be I central plus md squared by parallel axis theorem. And then that will be 3.17 plus the mass is 10 here, 4 of them, 8, which makes 18, times the d is 0.5 squared. That is plus 7.67. That is the moment of inertia for the whole body.